Hi, this is Vijayakumar Kadha. Today I am here to give my research article presentation on EEG-based seizure detection using temporal convolution neural networks and tree-based models. The co-authors are Rasool Reddy, me, myself, Surekha, Anil, and Madhusudan sir. I am from Department of EC, Amrita Vishwavidyapitham, Amaravati campus, Andhra Pradesh. Today I am here to give the presentation on 22nd International Conference, CSPA 2026. Before going to my presentation, this is my outline of the outline of my presentation: introduction, literature review, proposed methodology, results and discussion, and conclusions and future work, and references. So now I will start with the introduction part. So nowadays, most of the people are suffering with epileptic seizure, which is essential to the patients to detect early. So to do that, most of the works are already done on this. However, manually detecting EEG signal analysis is very complex and subjective process also. And the other part, the manual examining the long EEG signals is a labor intensive, subjective, and impractical for continuous monitoring situations. So to get the best detection part, as well as within less time to detect that, we required to propose a framework which can detect within less time and accurately. So to do so, we done the literature survey on applicable Caesar. So this on that, most of the works are working on that. But in that, most of the works are handcraft feature-based methodologies and deep learning frameworks are also introduced. So in handcraft feature-based methodologies, or LBP-MAD feature, or else discrete wavelet transformation was used for detect the features, and wavelet decomposition and continuous wavelet transform are also used. By using this, they used to detect get the features and followed by the classifiers which can detect the seizure detection. So in 9 they used end-to-end deep learning framework. They used residual modules and the inception modules also. So and hybrid deep learning frameworks are used. They used ML and DL fusion based methodologies also used. Ensemble learning was used. However, all most of the techniques which was used to detect EEG based epileptic seizure detection, mostly they are doing the work on um, they are not detecting outliers. So even though they want to detect that outliers, they are using basic interpolation techniques, which is which leads to a far less stable or less reliable. Apart from this, there is a class imbalance problem for EEG data also. That means one class is having higher samples and other class having low samples. So to balance that, they are using simple oversampling methodologies. So if we what we observed is that if we change that to if the data set is good enough for any DL model, then we can achieve the better performance. So as per that statement, we gone through a pre-processing methodologies by using IQR, interparental range, and the other method is for imbalancing problem, class in imbalance problem, synthetic sampling. Adaptive synthetic sampling was used. So by using these two, we detected outliers and class imbalance problem was identified. After this pre-processed data was given to a TCN network and followed by the classification module where RF and extremely randomized trees. Mostly we will call it as extra tree. So by using these two, we used these two to detect this seizure by through EEG. And finally, we achieved a better performance as compared to the state of the heart. So these are the key contributions of our work. And the next one is the proposed methodology. This is the workflow of my proposed methodology. Initially, we taken only one the dataset, bone EEG dataset. After that, outlier was detected. Further, data balancing part was done. After that, feature extraction part was obtained. Finally, classification. Finally, it was predicted whether it is yes or no. This is the framework which we used. So by using this, the first part is all about outlier detection. So you can observe these two figures where most of the EEG data having outliers. This outliers was detected by using IQ method. So by using that, the second diagram, you can observe that the outliers are some outliers are which are outliers that was removed. The clean and more consistent of training data was obtained after passing the raw data through this method. Next, after this, we have to balance the data. The data balancing problem can be most of the medical domain, the data set will be in balancing. So to make the balanced data set, we implemented adaptive synthetic sampling methodology, which synthetically samples, the generated samples are generated, and which was added to a minority sample elements. So in our data set, we have four scenarios: case one, case two, case three, case four. Among these, first three cases are binary classification, like yes or no. It will take is a Caesar or not Caesar, no Caesar. So fourth one is multi-class problem. So for this, we used four scenarios, like four cases, and we done that. After that, the feature extraction module. The low for this, we used temporal convolutional neural network that it is by using one-dimensional time-based data stream was given to this. For we have used three temporary blocks: temporary block one, temporary block two, and three, with different channels. 64, 128, 256 channels were used, and all these temporary blocks are having with three kernel sizes of each layer, and followed by a relay activation function. The dropout was also added because of word fitting problem. So after this, these residual connections are given to a temporary pooling, which was obtained very good seizure detection performance. See here, this is our block diagram, internal architecture of temporal convolutional neural network, three blocks, and all these three blocks are connected together by using global average pooling. And after that, we use fully connected layer. And final layer is all about the total number of neurons based on our problem. If it is binary, it will need two. If it is multi-class, we use three neurons as an output. So in the second layer, we use dropout layer to reduce the word fitting problem. And after that, the classification, we used after this, we used three methods like exact TCN, and for other two scenarios, we used random forest, and other one we used the tree, extreme tree methodologies. So after that, we measured this accuracy, precision, and recall, and a score specificity of our model, and we observed that the model was achieved better performance as compared to other state of the art. So the results and discussion part we will go for the dataset description. We used Bone EEG dataset. There are five sets. In that five sets means with different brain regions, they take the set and its condition, and finally it will give the type whether Caesar or non-Caesar. So if you observe, S2, S3, S4, S5 are the four sets which have non-Caesar category, and set one has Caesar category. And in non-Caesar category, by opening eye and closing. So in this way, they measured the Caesar and non-Caesar. So this data was given to our proposed framework, and we observed the ablation study also. In the ablation study, we use three different types of frameworks. Alone, the only TCN network, and other one is TCN followed by RF, which is random forest. Next, TCN followed by ET, which is extra tree. So based on these three scenarios, we obtain the performance, and we observed that most of the scenarios, like case one, case two, case three, case four, all the scenarios, the results, the performance of our proposed model is achieved per TCN followed by extra trees. So the tree-based methods. So that we taken that and we compared this analysis with the previous state of the art. So if we observe in this table, for case one, well, some few works are done. For case two, some other few works are done. Case three, few works. Case four, some one work was done. So not like that. We, as per our knowledge, we observed that one work was done, and we done, and we compared this. But Our proposed model can detect any type of seizure, like any type of scenario, any scenario, case one, case two, case three. In all scenarios, we achieved. For binary classification, we achieved now more than 99%. For multi-class problem, we achieved almost 95%, which is better as compared to previous state of the art. So this is the comparison model. If you observe here in the case one, 94 to 99 improvement was obtained, and for case two, 99 was obtained, and for case 3 we achieved 98.27, and the final case 4 we achieved 95% of scenario. Like this was done because of the pre-processing as well as the local features which were extracted by TCN and followed by trees. And the other part, and we also want to show the visualization of land TCN features. If you observe here, case 1 and 2 are excellent, classified very well, and case 2, case 3 also very good enough. However, some of the features, some of the samples are misclassified in the case of case 4. So this we have to improve further. So to do this, we are working on that. And the final conclusion of my work is all about we detected EEG seizure detection system. We effective EEG seizure detection system by using temporal deep learning framework and tree-based ML methods. So we also use two pre-processing methodologies to detect outliers and for imbalance problem. And however, this study is exclusively done on bone EEG dataset, which was well established. However, the some consist of RT-free and short duration recordings are also there. That complex of real clinical environments was there, not fully complex in real world scenario. So this is some of the limitation of our proposed work. In future, we are working on the proposed like network which can work on different data sets such as CHB or MIT dataset or TVH-EHB dataset. So that if that model is work on all these three data sets, then it can be very generalized and which is very efficient. So we are working on that. So we are expecting better performance on that also. So in Caesar monitoring applications, we can use that thing. So this is the conclusion and future work of our proposed work, and these are the references. And thank you very much. And if you have any queries, please